Hey everybody, the purpose of this video is to walk you through a quick little tutorial on question 10.9.16, and maybe to stop the camera from shaking. There we go. It's a quick little two-sample hypothesis test on two averages. There's a claim that four-year college average enrollment is higher than two-year colleges in the U.S. They did a sample of 70 schools, 35 in each category, and they got some sample statistics that are in your text. The important thing for me is not so much crunching the numbers, because your TI does that for you automatically. It's making sure you know what the claims are symbolically, making sure you're actually getting the data entered correctly. So there's two averages we're interested in, average 1 and 2, and it doesn't matter to me which one you call what, as long as you keep it straight in your mind. I want to keep mu1 as average enrollment at the four-year school, and mu2 as average enrollment at the two-year school. Okay? Seems fair. The claim is that the average enrollment at the four-year school is actually greater than the average enrollment at the two-year school. So that's the claim they're making. The null would be the opposite of that, or if you prefer just equals or less than or equal to, if you want that as well. Then we have to enter our data into the TI, which I've got here for us. And I've run the numbers, and I come up with a t-statistic of about negative 0.25, negative 0.25 standard deviations, and I get a p-value of over 0.5, about 0.6, about 60%. This tells me two things, interesting things actually. Number one, it tells me that the sample data actually indicates that the enrollment at the four-year colleges is lower than it is at the two-year colleges, because that bad boy is negative. But that doesn't bother me, because we're always going to have sampling deviation and sampling error. The fact that it's so close to zero, however, that's what's interesting. The fact that it's so close to zero. So you've got this wonderful bell curve centered on zero. If truly the average of the four-year schools was significantly greater than the average of the average of the four-year schools was significantly greater than the average of the two-year schools, you'd expect your test statistic to fall somewhere over here, trapping your 5% region over here. Conversely, it actually landed over here, which is nowhere near raised. It's actually a little bit lower, but more importantly, it's really close to zero. So you've got this beautiful contrary result from your study, although it's not really contrary. It's just that we can't make the claim that four-year schools are higher enrolled than two-year schools. We also can't claim that they're lower enrolled. We just can't claim that they're higher enrolled. So there you go. There's your crunches. Of course, with a high p-value, you could always make a type 2 error, meaning indeed they are higher enrolled and we just got deviant data. But more likely is the case, as long as our study was done correctly, with minimized type 2 error, that we just have a claim that doesn't really hold any water. Hope that helped.